In this demonstration, I'm going to walk through adding a machine to the domain and how to promote that machine to be a domain controller, all through Zscaler private access and branch connectors. So I've got my corporate data center. This is my physical location in the UK. The site is 192.168.1.0/24. My domain controller, dc3.welshgeek.net. It's a domain controller, so it's running DNS. That's running on .2, 192.168.1.2. DNS points to the loopback address, .2 and 127.0.0.1. That's how you configure domain controllers. This has a default gateway to get to the internet, which is the branch connector, .221. It's .221 because I used all the other IP addresses at the top of the range. The branch connector connects via my internet router at .254, and because it's a branch connector, DNS resolution is against Zscaler Zero Trust Exchange. Then I've got an app connector. IP address is .19. DNS is pointing at the domain controller, .2. Default gateway is my internet router, and so that avoids passing that traffic through the branch connector tunnels. So any Zscaler client connector, my Mac or Windows device, iOS, Android, can access things in my domain, resolving against the app connector. I can domain join them, and all of those things work. Got my Kerberos tickets and all of that kind of stuff. All through the app connector, accessing my resources here. As far as Active Directory is concerned, this is an AD site. It's called VLAN1 default for that subnet range. And so I've got a virtual data center. This is running in SkyTap in Texas, 192.168.255.0/24. Got the server, which is .1. Its DNS is currently .253, which is the branch connector. Default gateway is 253, which is the branch connector. The branch connector has its DNS is Zscaler, of course, and the default gateway is the router to get off the network, .254. The app connector is .20. Default gateway is 254 to get around the branch connector. Now its DNS is .1, so I've already configured, installed the role DNS and domain services on this server. So it's got the DNS running on there. So if this thing tries to resolve, it'll be able to resolve against this thing. It'll resolve, the app connector needs to resolve the internet. The way it resolves the internet is against this, which then resolves against that, which then forwards to the Zero Trust Exchange. So it's a bit of getting things set up in advance. I could configure the DNS for this to be pointing there, but I'd have to, once I promote this thing to be a domain controller, the app connector needs to resolve it. So it's just as easy to install DNS on it first, make sure the app connector is configured correctly, and then I don't need to touch the app connector again after I go through the DCPROMO and everything. Okay, so let's kind of show you a little bit of how that looks. So this is the app connector that's running in SkyTap. The resolve conf says, my name server is 192.168.255.1, and if it tries to get an SRV record, the locator service, for LDAP over TCP and welshgeek.net. It resolves that against this server that is running there. It's called branch, but that's forwarding it through the branch connector, which resolves it against ZPA and therefore against the app connector in my physical location. So I get the IP address 10.255.255.172. That's the synthetic IP address from ZPA. Okay, clear as mud. So let's just scroll across here and let's take a look at Active Directory. So I've got Active Directory sites and services. Let's actually refresh this because that server no longer exists. In fact, we delete that because that was from before I reset my session to record the video. Okay, so here's my DCPROMO location site. It's associated with the range 255.0. My VLAN 1 is associated with 1.0. My domain controller, which is this server itself, DC3, is in that VLAN, and I've got an intersite transport over IP that says ZPA has a link between these two sites. Okay, and if we come into sites and services, let's just refresh this. Oh, sorry, users and computers. I've got one domain controller, and let's refresh this just to double check. And I've got a bunch of other servers in there, but no server in there called branch. So that's all working. And then I'll just have a quick run through DNS, because DNS is really important to how ZPA functions. So everything with an underscore, these are SRV records, kind of, well, not everything, but most of the things with underscores are SRV records. This is telling me where I can connect to get Kerberos, where I can get LDAP from, about my AD sites, what's going on in each of those sites, what the domain controllers, something in that site should talk to. I've only got one domain controller, so it's DC3 for all of them. And then the dynamic Microsoft data center services or domain controller services kind of feed all that stuff down. So all of these are wildcards, but it's worth understanding some of these GUIDs that get created. We can, for the most part, allow these things to resolve themselves and enumerate themselves through DNS. Most of these are SRV records, but if we look at the root has one CNAME, which is an alias for the domain. So when something tries to connect, once it's joined to the domain, we'll get a GUID created, and it'll be an alias, the unique identifier for certain resources. So these things need to be resolvable. The SRV records need to exist in ZPA for it to resolve, and so we need to make sure there's a representation of this. Now, I can run an API call and pull all of this stuff out of Active Directory dynamically and push it into ZPA to make sure that all works. You haven't got to copy and paste all this stuff back and forth. Automation using the Zscaler APIs will enable you to create these app segments correctly. Okay, so let's just come back across here and we'll jump into ZPA. And here is the representation. In fact, before I do that, let me just go to the diagram. There's a really important nuance here. Most of the things we do in Zscaler, or indeed my recommendation, is always do things by FQDN, fully qualified distinguished name, your DNS entry. And you would, my client connector, when it tries to connect to the domain, it's going to do that DNS SRV lookup. It's going to connect to the dc3.wellsgeek.net. Everything's going to be DNS based. The important distinction on this, though, is when you start talking about domain controllers resolving each other and replicating between each other, because they actually end up pointing to themselves. The DNS on this is .2, so it's looking up itself directly. The DNS server here is .253, only because that's what it's configured to be. Once this becomes domain joined, this will get reconfigured to point to the loopback address, because it says, well, I'm a DNS server myself. I should be authoritative for what I see as the domain. Okay, so if this server, this branch, suddenly gets a replica of the domain, everything in the DNS, and it's configured to point to itself, 127.0.0.1 for DNS resolution, it's going to say, hey, I need to talk to dc3.wellsgeek.net, but it's going to resolve it locally, and it's going to get the 192.168.1.2 address for it. And you can't get around that. Or you can, but everything would be messy, because you'd say, well, everything's got to talk through this thing, which is the branch connector. And so even when it's talking to itself and loop back, it's going all the way out to the Zero Trust Exchange and back. So when we look at the policy, I do have some policy here, or some app segments, which are the real IP addresses of the servers. So we're going to pay really close attention to that. I've got my domain controllers, DC3, and I've got that CA, you know, that this alias here, that's propagated. It's got a wildcard star dot in front of it. That means that the client can receive the canonical name, so the alias. So when the client tries to resolve this, they'll actually get the alias DC3, and we'll get the synthetic IP address track. So that's what that star dot in front means. So we've got the domain controller in the data center defined as both its FQDN and the alias. And if we click on this, let's run through. We've got our Kerberos ports, TCP and UDP. We've got our LDAP ports, TCP and UDP. We've got the SMB and the file share and the enumeration of the domain on 135, 137 to 139. We've got our CIFS ports. We've got our encrypted LDAP. We've got the high ports for the RPC. We've got the global catalog 3268 to 3269. We've got a web server on there. We've got the 9389, which is the domain discovery protocol, which is necessary for it to figure out what services are running on the domain controllers. And then we've got 53 for the DNS replication. Now, I mean, really explicit on DNS, we would ordinarily say, do not configure an app segment with port 53 in it. And we will adhere to that. However, the specific guidance is you shouldn't have an IP address defined with port 53. Having an FQDN and port 53 is not a problem because you'll always get the ephemeral or the synthetic IP address returned, and connecting to port 53 is kind of fine on that. What you don't want is an IP address with port 53, your client connector gets that IP address, you know, and suddenly you're trying to resolve something, but you're getting the real IP address back because the DNS gets mangled. So you don't want an IP address with port 53 getting down to your client connected devices. Okay, so we'll go through what we're doing here. So I've got my domain controller in the data center. It's associated with my server group, which is the data center server group, which has only got the one app connector group in there. I've got the same for the things that are up in my SkyTap, with the branch server group, which only contains the branch app connector up in SkyTap. And then I've got the IP address for that as well. Now, the IP addresses are in a segment group called DC by IP. So if I come across to my policy, we go to our client forwarding policy, I have a rule here that says DC by IP is going to be forwarded to ZPA for the branch connector in the data center or the branch, but it's going to be denied for everything else, bypass ZPA for everything else. So this has the effect that the branch connectors get the definitions of how to handle that IP traffic and the ports associated with it, but none of my client connectors, in fact, nothing else gets those definitions. If something tries to connect to 192.168.1.2 on port 53, guess what? The client connector knows nothing about it. It'll just root, or it'll be blocked, or it'll go to ZIA and be denied at that point. But this is us restricting that that policy. Okay, so we've got a good understanding of the architecture. What's connecting to what? This server is standalone. We're going to join this server to the domain, welshgeek.net. We're going to do that first. This machine will restart, and once it's restarted, then we'll promote it to a domain controller. So let's jump onto ZPA first, and we'll go to Analytics, and we'll click on Live Logs, and we'll see what's going on here. So this server is here, so we can go local server. Work group is unknown. It's in the WG work group. So we're going to come in here and we're going to say add it to the domain welshgeek.net. I'll click OK. I'll give it an administrator password. And what it'll do is it'll do that DNS SRV lookup. It'll say, oh, give me the LDAP TCP welshgeek.net. Oh great, I've got the answer, it's the domain controller there. I'll go and make that connection. I'll exchange Kerberos tickets, or I'll join Kerberos, exchange some tickets, and I'll join the domain. That shouldn't take too long. There we go, welcome to the welshgeek.net domain. We can click OK, ooh, OK, oh, close, and it'll say restart now. Whilst that's restarting, let's come across here, we see it generated 94 transactions, all from the provisioning key or the location. We've got some stuff here from my user traffic in the background, but you can see did the UDP transaction, so that's a connectionless LDAP, so that's enumerating sites and services. It connected to CIFS, it did some Kerberos stuff, it did some TCP 389, so there's a lot more Kerberos going on, getting Kerberos tickets. We could have done a packet capture to look at that traffic. We see the high port here after the RPC call, so this is global catalog, SMB traffic, exchanging the data, and then we see that it did get the real IP address back, and it made some connections and all of that. Did exactly what we thought. Also 123 is the NTP, and here is the connection to that that GUID on port 445 as well, which is necessary for the group policy. So you've got to understand how all that DNS works. Well, not necessarily understand it, but appreciate it for it to work. So if we come back across here, well, it's still doing something, it's figuring things out. Hopefully life is good. Okay, so we see it rebooting. It's got a lot of traffic going on there to get its group policy and things, and that's all working fine. So we've rebooted. Pulling down all the group policy objects. One quick note on that group policy specifically. Let's log in here and I'll show this. So I want to log in as that's all right, administrator. So I've now joined this machine to the domain, and it's routing everything and connecting through to the internet as well as ZPA through the branch connector. And my policy here has SSL inspection enabled. So if I just quickly open up Internet Explorer, which will probably go to Microsoft or Bing or something, MSN, you'll see that it's SSL inspected. So the group policy is pushing down the TLS inspection certificate to make sure that that chain of trust for Microsoft.com, everything that's intercepted, is working correctly. So just be familiar with that. Not necessarily a problem in terms of this connectivity to the domain and promoting it to a domain controller, but be aware that I've now got a server that's connecting to the internet. SSL inspection policy is going to be applying. Okay, so it's booted up. It's part of the domain. We're in the domain now. If we come across to my domain controller over here, let's refresh. We can see that the machine branch was created, and it tells us that it's a 2019 server. Okay, so now what we're going to do, we come to directory services and we'll say needs to promote to a domain controller. So let's let this thing figure things out. So it's going to go off and figure out the domain. It says domain is welshgeek.net. I want to add it into the existing domain, so we click next. going to figure out the AD site, so that's based on what my IP address is, what the IP address that it's seen by the domain controller coming from. This thing needs to be a DNS server. It's going to get a replica of the global catalog. We'll wait for that to finish. Whilst that's doing that, we'll jump back over here. Oh God, there's a lot of logs going on. It's connecting to SMB. We've got all that UDP and TCP LDAP traffic. The UDP is really about it trying to enumerate where it exists in the domain. Where am I? What is my site? And for some reason, it hasn't been able to figure that out. So let's give that another go. There we go, it's figured it out. So let's give it the restore password to join the domain. And it's going to replicate from, it'll figure out what domain controllers are available. There is only one, so it shouldn't take 2 seconds to figure that out. Click next. Happy with the default paths. Let it review. It's just going to check if there are any prerequisites that are necessary before it can be promoted to a domain controller. We're happy with all of that, and we can now click install. And the server will reboot at the end of it, but it's looking for the domain controller, checking the forest status. It'll start replicating all of the objects shortly. Okay, so we start replicating the policy. We see the objects replicating. Okay, it's updating the DNS service. Let's take a look at ZPA. You know, we've got loads of logs coming through now. So we'll have seen all of the RPC traffic. Here are those connections to that GUID. So all the replication is happening. We do see things by IP address. We'll see more of those as it comes through and it restarts. Okay, so it's been successfully configured. It's now going to restart. Okay, so we've restarted. So you can go through its discovery process and everything. Let's go to Tools, Users and Computers, Tools, Sites and Services. Only thing that I think we might need to do okay, so AD sites, so it's resolving the sites. We can see DCPROMO site here, which I'm in. So it's added the branch there. So we know that the branch is in the site. We can come here. And I think what's happening here is it's slow because it's going across the ZPA connection. So it says the operations. Yeah, I think it's connecting to. Yeah, it's connecting to DC3 specifically. And I think yeah, see, it's still got, I should have changed this. Okay. So now it's going to resolve. Into the real IP address because it's going locally, but it's also ping branch.welshgeek.net, which should be itself. This is where it was complaining about the DNS. So let's check the DNS server. So it's replicated everything. The only thing it doesn't have an entry for is branch. So it's got branch there. Huh. Cool. So it's registered itself correctly. So we should, if we close these out, okay, so it's now connected to itself. We should be able to see all the domain controllers and the branch. There we go. Okay, so I think the important lesson is I should have reconfigured it to be a point to itself for DNS before I replicated, because it was then trying to figure out, do I talk to the the DNS answer I get from the branch connector or the answer I get from myself. So we've now got the two domain controllers. This was promoted, or is joined to the domain, promoted to be a domain controller, replicated, and everything's working as it should. Hope this is helpful. Mark@zscaler.com.